Imagine standing on the surface of Mars. The sky above you is not blue, but a dusty orange. The air is so thin that every breath would be impossible without technology. Temperatures can plunge far below anything experienced in most places on Earth. Deadly radiation falls from space. Massive dust storms can cover entire regions of the planet. And if something breaks, there is no rescue team just hours away. Home is not across an ocean. Home is tens of millions of kilometers away. For decades, Mars has been presented as humanity's next great destination. A second world, a future colony, a backup planet for our civilization. But the reality is far harsher than most people realize. In this documentary from What If Beyond, we will explore the brutal truth about living on Mars. Why haven't humans settled there yet? What dangers await the first colonists? How much would it cost to survive on a world that seems determined to kill you? And could Mars ever truly become a second Earth? Before we begin, take a moment to subscribe to What If Beyond if you enjoy deep space documentaries like this one. And tell us in the comments, what time is it right now, and which city are you watching from? Now, dim the lights, get comfortable, and let's begin our journey to the most dangerous world humanity dreams of calling home. Mars looks close because we've been dreaming about it for so long. It appears in science fiction as the next world, the first step toward becoming a multi-planet civilization. A red horizon where humans will build cities under glass domes, grow food in glowing greenhouses, and look back at Earth as the place where the story began. From far away, Mars feels almost familiar. It has days similar in length to Earth's days. It has seasons. It has mountains, valleys, polar ice caps, dry riverbeds, ancient lake basins, dust storms, and landscapes that look strangely similar to deserts on our own planet. But the closer we look, the more that familiarity disappears. Mars is not Earth's smaller sibling waiting patiently for us. Mars is a frozen, irradiated, airless, dry, unstable world where every basic human need becomes a technical problem. Breathing becomes a problem. Water becomes a problem. Heat becomes a problem. Radiation becomes a problem. Food becomes a problem. Power becomes a problem. Distance becomes a problem. Even dust becomes a problem. And that is the first truth we have to understand. Colonizing Mars is not difficult because of one single obstacle. It is difficult because every obstacle connects to every other obstacle. On Earth, survival is supported by the entire planet. The atmosphere protects us. The magnetic field shields us. The oceans regulate temperature. The soil supports plants. Gravity holds our bodies in the environment they evolved for. Air pressure surrounds us without us thinking about it. Water falls from the sky, flows through rivers, and fills lakes and oceans. On Mars, none of that is waiting. Everything that keeps a human alive has to be brought, built, powered, repaired, recycled, protected, and monitored. The first humans on Mars would not simply be explorers. They would be living inside a machine that protects them from the planet around them. A habitat on Mars would not be like a house. It would be more like a spacecraft sitting on the ground. The walls would need to hold pressure. The systems would need to provide oxygen. The air would need to be filtered. The temperature would need to be controlled. Carbon dioxide would need to be removed. Water would need to be purified again and again. Waste would need to be managed. Every seal, pipe, valve, cable, battery, pump and sensor would matter. A small failure on Earth is an inconvenience. A small failure on Mars can become a crisis. This is why Mars is brutal. Not because it is dramatic every second, but because it gives almost no forgiveness. The first challenge is the atmosphere. Mars has one, but not the kind humans need. The Martian atmosphere is extremely thin compared to Earth's. It is mostly carbon dioxide, with only tiny traces of oxygen. If a person stood outside without a suit, they could not breathe. The air pressure is far too low. The oxygen is not there. The cold would be extreme. The environment would overwhelm the body very quickly. So every human on Mars would need protection at all times. Inside a habitat, pressure would need to be maintained. Outside, a spacesuit would be required for even the simplest task. Walking outside to check a solar panel would become a planned operation. Fixing equipment would require preparation. Collecting samples would take time. Even moving from one module to another might require careful procedures if the structures are not directly connected. On Earth, we walk out the door without thinking. On Mars, leaving the habitat means entering a hostile world. That changes everything about daily life. A colony is not just a collection of buildings, it is a survival system. Every door is an airlock. Every window is a structural decision. Every room is part of life support. Every outside trip consumes resources, time, and energy. Even the simple act of bringing dust inside could become a problem. Martian dust is not like ordinary dirt in a garden. It is fine, dry, clingy, and potentially harmful to machines and humans. It can cover solar panels, it can stick to suits, it can enter seals, it can damage moving parts, it can reduce visibility, it can create maintenance problems everywhere. On the Moon, astronauts discovered that dust was far more annoying and dangerous than it looked. Mars could create similar problems, but on a much larger and longer timescale. Imagine a colony after months or years of operation. Dust on equipment. Dust in joints. Dust around airlocks. Dust on rover wheels. Dust on panels. Dust in filters. Dust carried inside on suits. Every day becomes a battle against tiny particles. And because Mars is dry and cold, the dust does not simply wash away with rain. There is no comfortable weather system cleaning the settlement for you. The planet does not maintain itself for human needs. Humans would need to maintain everything. Then comes temperature. Mars is cold. Very cold. Its thin atmosphere cannot trap heat the way Earth's atmosphere does. Temperatures can swing dramatically between day and night. In some places and seasons, conditions may become slightly less extreme during the day, but the overall environment remains hostile. A habitat must stay warm. Water systems must not freeze. Electronics must remain within working limits. Batteries must be protected. Pipes must be insulated. Spacesuits must regulate body temperature. Greenhouses, if used, must be carefully controlled. Heat becomes not just comfort, but survival. On Earth, cold weather is something people dress for. On Mars, cold is part of the engineering design of every system. And cold is only one side of the problem. The other side is radiation. Earth has a thick atmosphere and a magnetic field that protect life from much of the radiation coming from space and the sun. Mars does not have that same level of protection. Its atmosphere is thin. Its global magnetic field is gone. Radiation reaches the surface far more easily. This is one of the biggest problems for long-term human settlement. A short visit might be managed with limited exposure, but a permanent colony would require serious protection. Habitats may need to be covered with soil or built partly underground. Living spaces may need shielding. Storm shelters may be required during solar events. People may have to spend much of their time inside protected areas. This changes the dream of Mars. The popular image is beautiful glass domes under a red sky. But glass domes are not the easiest answer. A transparent dome looks inspiring, but radiation, pressure, impacts, temperature changes, and structural stress all make it difficult. The safest early Mars habitats may look less romantic. Buried modules, lava tubes, thick walls, covered structures, small windows or no windows. A settlement designed not for beauty first, but for survival. The first Mars colony may feel less like a futuristic city and more like a remote scientific station mixed with a submarine, a spacecraft, and a bunker. This does not make it less incredible. It may make it more impressive. Because every day on Mars would be a victory of engineering over environment. But it also means colonization would not begin with comfort. It would begin with limitation. Limited space. Limited supplies. Limited privacy. Limited movement. Limited outdoor time. Limited rescue options. Limited margin for error. And this brings us to another brutal truth. Mars is far away. Not far in the way another country is far. Not far in the way the moon is far. Mars is deeply far. The moon is close enough that astronauts reached it in a few days. Communication delay is short. If something goes wrong, Earth can respond quickly, at least compared to interplanetary distances. Mars is different, depending on where Earth and Mars are in their orbits. The distance changes enormously. Signals can take many minutes to travel one way. A real-time conversation is impossible. Emergency instructions from Earth would arrive late. Replies would arrive late. Every decision on Mars would need local independence. A Mars crew cannot depend on mission control the way astronauts in low Earth orbit can. They would need to diagnose problems themselves, repair systems themselves, make urgent decisions themselves. And if a major failure occurs, there is no fast return, no immediate rescue ship, no helicopter, no hospital across town, no emergency backup team arriving in hours. The distance turns Mars into one of the most isolated environments imaginable. Even Antarctica, one of the harshest places on Earth, is still on Earth. It has breathable air, it has normal gravity, it has a sky protected by the same planet. Rescue may be difficult, but it is not interplanetary. Mars is a different category. A Mars colony would be alone in a way no human settlement has ever been alone. This affects technology, but it also affects psychology. Imagine living on a planet where Earth is only a bright point in the sky. Every person you know is either inside the settlement with you or unreachable in any normal sense. Messages from home arrive delayed. News arrives delayed. Conversations with family cannot happen naturally. If you feel fear, frustration, loneliness, or stress, there is no easy escape from the environment causing it. You cannot go for a normal walk outside. You cannot breathe fresh air. You cannot feel rain. You cannot stand under trees. You cannot hear birds. You cannot swim in an ocean. You cannot open a window. The colony would have to provide not only oxygen and food, but emotional stability. This is often underestimated. Mars is not only an engineering challenge, it is a human challenge. People are not machines. They need routines, meaning, social connection, beauty, privacy, rest and hope. A Mars settlement would have to be designed for minds as well as bodies. Lighting would matter. Sound would matter. Personal space would matter. Community spaces would matter. Food variety would matter. A connection to Earth would matter. Even plants may become psychologically important, not just nutritionally useful. A small greenhouse might mean more than calories. It might mean colour. Life, freshness, a reminder of the planet humans came from. Because Mars itself offers very little softness. Its landscapes are magnificent, but they are not alive in any obvious way. No forests, no grass, no animals, no open water, no breathable breeze, no natural shelter from radiation. The beauty of Mars is cold, silent and distant. That beauty may inspire the first explorers, but living with it every day could be heavy. A person can love the view and still miss home. This is one reason colonizing Mars is harder than visiting Mars. A mission can survive discomfort for a limited time. A colony must transform discomfort into a lifestyle. That requires a deeper level of stability. For a colony to truly exist, it cannot depend entirely on Earth forever. At first it will. The first missions would bring supplies, tools, spare parts, food, equipment, habitats, rovers, power systems, medical supplies, and communication systems from Earth. But a permanent settlement must eventually produce some of what it needs locally. This idea is called using local resources. On Mars, that could mean extracting water ice, using carbon dioxide from the atmosphere, producing oxygen, making fuel, building materials from Martian soil, and growing food inside controlled environments. In theory, this is one of the reasons Mars is attractive. It has resources, it has carbon dioxide, it has water ice, it has minerals, it has a surface where equipment can land and operate. But having resources is not the same as using them easily. Water ice may be buried, mixed with soil, located in specific regions or difficult to extract. Processing it requires energy and equipment. Equipment can break, filters clog, pipes freeze, systems require maintenance. Energy must be available consistently. Making oxygen from the Martian atmosphere is possible in principle, and experiments have shown early steps toward this. But a colony would need reliable, large-scale production. Not once, not as a demonstration. Continuously, fuel production would also be essential if humans want to return from Mars or move around more freely. That requires chemical processing, storage, power, and safety systems. Growing food sounds simple until we remember that Mars has no open farmland. Plants would need controlled pressure, temperature, water, nutrients, lighting, and protection from radiation. Martian soil is not ready to use garden soil. It may contain chemical compounds that are harmful and would require treatment. Nutrient cycles must be created. Water must be recycled. Crops must be protected from disease and system failures. A failed crop on Earth is a financial loss. A failed crop on Mars could threaten survival if the colony depends on it. This means early Mars settlers would need redundancy, backup systems, backup food, backup power, backup oxygen, backup water processing, backup communication, backup tools, backup parts. But backups increase mass, and mass is one of the most expensive things in space exploration. Every kilogram sent to Mars must be launched from Earth, accelerated through space, guided across millions of kilometers, slowed down, and landed safely on another planet. Landing on Mars is especially difficult. Mars has enough atmosphere to create heat and turbulence during entry, but not enough atmosphere to slow a spacecraft easily like Earth. It is the worst of both worlds in some ways. A spacecraft must survive entry, descend through thin air, and land heavy cargo safely. Small robotic landers have succeeded. Larger human-class cargo is much harder. A real colony would require massive amounts of material. Habitats, power systems. Rovers, life support. Food, water systems. Construction equipment. Science tools. Medical equipment. Communication arrays. Spare parts. Radiation shielding. Everything needed to survive. Before humans even arrive, large amounts of cargo may need to be pre-landed and tested, because sending people first and hoping the rest works later would be too dangerous. A serious Mars colonization plan would likely require many launches, many landings, and a long build-up of infrastructure. This makes Mars not only hard, but expensive. Extremely expensive. And cost is not just money. Cost is complexity. Every mission must work. Every system must integrate. Every delay matters. Every mistake becomes amplified by distance. A single colony depends on a chain stretching from Earth factories to launch pads to orbit to interplanetary transfer to Mars entry to surface operations. That chain must be reliable, again and again, for years, maybe decades. This is why the idea of simply going to Mars can be misleading. A landing is not a colony. A flag is not a civilization. A few astronauts on the surface would be historic, but colonization requires continuity, people staying, more people arriving, systems expanding, food production improving, power increasing, habitats growing, local manufacturing developing, medical capability expanding, children, perhaps someday, being born and raised there, a society forming that is far beyond the first landing. It is one thing to survive on Mars for months. It is another to make Mars a place where human life can continue generation after generation. And when we say it like that, the difficulty becomes enormous. Because human bodies evolved for Earth, Mars has lower gravity. This may seem helpful at first. You would weigh less. Moving heavy objects might be easier. Launching from the surface requires less energy than Earth, but long-term low gravity may create health problems. We know that microgravity in space affects muscles, bones, fluids, vision, and the cardiovascular system. Mars gravity is stronger than microgravity, but still much weaker than Earth's. We do not yet know exactly how the human body responds to living for years or lifetimes under Martian gravity. Can children develop normally there? Can pregnancy happen safely? Can bones remain strong? Can muscles adapt? Can the heart and circulation function long term? These are not small questions. A true colony depends on human biology, not only rockets and habitats. If Mars gravity causes serious long-term health issues, colonization becomes much harder. People might live there temporarily, but building a permanent multi-generational society could require solutions we do not yet have. This is one of the biggest unknowns. Mars is not just a place to reach. It is a place the human body must be able to inhabit. And the honest answer is that we are still learning. Then there is medicine. On Earth, modern medicine depends on enormous systems: hospitals, specialists, labs, supply chains, medicines, imaging machines, surgical teams, blood supplies, replacement parts, sterile environments, emergency transport. A Mars colony would begin with only a tiny fraction of that. If someone becomes seriously ill, treatment options may be limited. If someone needs surgery, the colony must be prepared. If an infection spreads, isolation and treatment become critical. If equipment fails, there is no nearby warehouse. If a medication expires, resupply could be months or years away. Medical independence is one of the hardest parts of settling another planet. A colony would need trained medical staff, diagnostic tools, pharmaceutical supplies, and perhaps eventually the ability to produce some medicines locally. But again, that adds complexity. Every system needed for civilization becomes harder when it must be transported across space. This is the pattern we keep seeing. Mars does not present one wall. It presents thousands of smaller walls. Each one can perhaps be solved, but solving all of them together is the true challenge. And this is why the dream of Mars must be treated carefully. There is nothing wrong with dreaming. In fact, every great achievement begins with imagination. But imagination must eventually meet reality. Mars will not become a second Earth quickly. It may never become a true second Earth in the way people imagine. Terraforming Mars, changing the entire planet to make it more Earth-like, is far beyond our current ability. The atmosphere is too thin. The planet is too cold. It lacks a strong global magnetic field. Creating a breathable atmosphere would require resources and timescales almost beyond comprehension. So the first real Mars settlements would not be open-air cities. They would be enclosed, protected, dependent on technology. Human life would exist inside carefully engineered bubbles. Outside those bubbles, Mars would remain Mars. Cold, dry, thin-aired. Unforgiving, and maybe that is the real reason Mars is so fascinating. Because it sits between possibility and impossibility. It is not completely unreachable, but it is not welcoming. It is not impossible to explore, but it is extremely hard to inhabit. It is close enough to tempt us, but harsh enough to humble us. Mars invites humanity forward while warning us that nature does not care about our dreams. This tension is what makes the question so powerful. What is actually preventing us from colonizing Mars? The answer is not simply distance, or money, or rockets, or radiation, or food, or dust, or psychology, or gravity. It is all of them, together, stacked on top of one another. Interconnected, a planet-sized puzzle where every solution creates new requirements. A Mars colony must be a spacecraft, a village, a laboratory, a power plant, a farm, a factory, a hospital, a recycling system, a communication network, and a psychological shelter all at once. It must work in a place where the air cannot be breathed, the cold can break machinery, radiation reaches the ground, dust invades systems, water is difficult to access, rescue is far away, and every mistake matters. That is the brutal reality. And yet, humans are still drawn to it. Maybe because Mars is hard. Maybe because it represents the next threshold. Maybe because reaching it would prove that humanity can survive beyond Earth, at least in some form. Maybe because the red planet has always occupied a strange place in our imagination. A world close enough to see, far enough to challenge us, alien enough to frighten us, familiar enough to make us wonder. The first settlers, if they ever arrive, will not step into paradise. They will step into a test of engineering, a test of courage, a test of patience, a test of cooperation, a test of whether human civilization can build a small pocket of life on a world that offers almost none of the comforts that made civilization possible in the first place. And before we imagine cities, forests, oceans, and open skies on Mars, we must first imagine something much smaller, a sealed habitat, a few people inside, machines humming through the night, air pumps running, water recycling, lights glowing over small plants, a rover parked outside under a dusty sky, the sun rising weakly over a cold horizon, Earth shining somewhere above, too far away to help quickly, and every person inside that habitat understanding one thing clearly. They are not living on Mars because Mars wants them there. They are living because human intelligence has built a fragile island of survival on a planet that remains completely indifferent to their presence. That is where the colonization of Mars truly begins. Not with domes, not with cities, not with grand speeches, but with survival. And survival on Mars will be brutal. Before the first real Mars colony can survive on the surface, it must survive the journey. This is the part that often gets hidden behind beautiful artwork. We see images of red deserts, glowing habitats, astronauts walking beneath a salmon-coloured sky, and large rockets standing proudly beside futuristic bases. But before any of that exists, every kilogram of material has to cross interplanetary space. And that journey is not simple. Mars is not always the same distance from Earth. Both planets are moving around the Sun at different speeds on different paths. Sometimes Mars is relatively close. Sometimes it is on the opposite side of the Sun, far beyond convenient reach. This means missions to Mars are usually planned around launch windows. A launch window is a period when Earth and Mars are positioned in a way that makes the trip more efficient. These opportunities come roughly every 26 months. If something goes wrong and a mission misses the window, it may need to wait more than 2 years for another good chance. That alone changes the entire logic of colonization. A colony on Mars cannot depend on daily shipments. It cannot depend on weekly resupply. It cannot even depend on yearly rescue. Everything must be planned in long cycles. If a crucial machine breaks at the wrong time, a replacement may not arrive for years. If food supplies are miscalculated, there is no quick correction. If a landing mission fails, the next attempt may be delayed by orbital mechanics itself. On Earth, distance is often a problem of transportation. On Mars, distance is a problem of time. A supply chain to Mars would be one of the most difficult supply chains ever attempted. Factories on Earth would need to build equipment strong enough to survive launch, deep space travel, radiation, vibration, temperature changes, months of cruise, entry into the Martian atmosphere, landing shock, and then years of operation in a dusty, cold environment. A single cargo mission may take months to arrive. During that time, nothing can be repaired by hand. No technician can walk over and tighten a bolt. No engineer can open a panel and replace a component. The spacecraft must protect itself until it reaches Mars. And then comes one of the most dangerous steps of all. Landing. Mars has always been difficult to land on. It has an atmosphere, but the atmosphere is too thin to make landing easy. It is thick enough to create heat during entry, but thin enough that parachutes alone are not enough for large payloads. Spacecraft must slow down from interplanetary speeds, survive intense heating, deploy systems at the right moment, and touch the ground safely. For small robotic landers, this is already difficult. For heavy cargo, it becomes much harder. For human habitats, fuel factories, power systems, and construction equipment, the challenge grows even more serious. A future colony would need massive amounts of cargo delivered successfully before the first settlers can truly rely on the surface. Imagine sending a complete survival system to another planet in pieces. One mission brings a habitat, another brings power units, another brings rovers, another brings tools, another brings food, another brings spare parts, another brings systems for making oxygen and fuel, another brings communication equipment, another brings scientific instruments. Each one must land close enough to be useful. If one lands too far away, retrieving it may be difficult. If one crashes, the entire plan may be affected. If one arrives damaged, the crew may have to improvise before they even begin building. A colony is only as strong as the infrastructure waiting for it. This is why the first human landing on Mars may not look like the beginning of a city. It may look like a carefully staged operation around equipment that arrived earlier. Before humans step out, robotic missions may need to prepare the site. They may need to test local resources. They may need to confirm water accessibility. They may need to deploy power systems. They may need to produce oxygen or fuel. They may need to check that communications are stable. They may need to make sure the landing zone is safe. Mars colonization begins long before humans arrive. It begins with machines. Machines scouting. Machines digging. Machines testing. Machines building the first fragile layer of survival. And this creates another challenge. Robots on Mars are useful, but they are slow. Because of the communication delay, many robotic operations cannot be controlled like a video game in real time. Commands must be planned, sent, executed, checked, and adjusted. Even with autonomy, machines must be cautious. A rover that gets stuck can lose an entire mission. A robotic arm that damages equipment could create serious problems. So preparing Mars remotely may take years, perhaps decades. The dream of quick colonization has to confront the slow reality of planetary construction. On Earth, building a settlement requires roads, workers, vehicles, cranes, supply trucks, warehouses, power lines, water pipes, and access to replacement materials. On Mars, the first construction crew may have none of that. They would need to bring their own industrial base. And industry is heavy. That may be one of the biggest hidden obstacles to colonizing Mars. A true civilization is not just people living in habitats. It is production. It is the ability to make, repair, adapt, and expand. A colony that cannot manufacture anything important remains dependent on Earth. It may be a base. It may be an outpost. It may be a research station. But calling it a real colony becomes difficult if it cannot support itself in meaningful ways. To grow, Mars settlers would need local manufacturing. They would need to make building materials. They would need to repair machines. They would need to produce spare parts. They would need to process soil, ice, metals, gases, plastics, and chemicals. They would need workshops, tools, printers, furnaces, reactors, storage systems, and trained people who understand how to keep everything running. This is where Mars becomes less like an adventure and more like an entire industrial puzzle. A single missing part could stop an essential machine. A broken pump could affect water. A broken seal could affect pressure. A broken battery could affect power. A damaged rover could reduce mobility. A failed software system could interrupt operations. On Earth, modern civilization hides this complexity from us. Most people do not see the supply chains behind their daily life. Food appears in stores, water comes from taps, electricity comes from outlets, buildings are repaired by specialists, tools are ordered and delivered, medical supplies arrive through global networks. Mars removes that convenience. Every object has a story, every tool has a cost, every replacement part has to be either brought from Earth or made locally. This means the first colonists would need to become generalists in a way modern people rarely are. They would need scientists, engineers, doctors, farmers, mechanics, technicians, pilots, programmers, builders, chemists, and emergency problem solvers. But they would also need people who can work across roles. A person may need to understand biology and plumbing. Another may need to repair a rover and monitor power systems. Another may need to grow food, manage waste recycling, and help with medical care. Mars rewards flexibility. A highly specialized person can be valuable, but a colony needs people who can survive when the plan breaks. Because the plan will break, not necessarily catastrophically, but constantly. A sensor stops responding, a filter clogs, a valve freezes, a panel loses output, a rover wheel degrades, a habitat wall develops a problem, a crop grows poorly, a battery performs worse than expected, a communication antenna needs adjustment, a suit joint wears down. On Earth, maintenance is part of life. On Mars, maintenance is survival. The first settlement may spend much of its time simply fighting decay, not dramatic disasters, not cinematic emergencies, but routine technical pressure. Every day, systems must be checked. Every week, parts must be inspected. Every month, supplies must be measured. Every season, risks must be reassessed. Colonization is not only about arriving, it is about keeping the machines alive long enough for humans to stay alive. Power becomes central to everything. Without power, a Mars base fails. Power runs life support. Power heats habitats. Power pumps water. Power processes air. Power drives communications. Power supports scientific tools. Power runs greenhouses. Power charges rovers. Power helps produce fuel and oxygen. Power keeps the settlement from becoming a frozen metal shell on a dead planet. The obvious option is solar energy. Mars receives sunlight, but less than Earth. Solar panels can work, and robotic missions have used them successfully. But solar power on Mars has weaknesses. Dust can cover panels. Seasonal changes can reduce sunlight. Large dust storms can darken the sky. Panels must be cleaned or designed to tolerate reduced output. Energy storage is required for nights and periods of low sunlight. A colony cannot simply hope the weather stays favourable. It needs reliability. This is why many people discuss nuclear power for Mars. A compact nuclear system could provide steady electricity regardless of sunlight, dust or season. That would be extremely valuable for a settlement. But nuclear systems bring their own challenges. They must be launched safely, landed safely, operated safely and protected. They require engineering, maintenance, shielding and planning. A real colony may use multiple power sources. Solar arrays spread across the surface. Nuclear units for stable baseload power. Batteries for storage. Backup generators. Careful energy management. Because on Mars, power is not just a utility. Power is life. This creates difficult choices. If energy is limited, what gets priority? Life support must come first. Then heating. Then water processing. Then communications. Then food systems. Then manufacturing. Then science and expansion. A growing colony would always be balancing ambition against available energy. Want to build more habitat space? That requires power. Want to grow more food? Power want to process more ice? Power want to produce return fuel? Power want to manufacture materials? Power Mars does not just require technology, it requires an energy economy. The settlement would need to think like a small civilization from the very beginning. Energy in, waste out, water recovered, air recycled, materials reused, systems repaired, every resource counted. This is very different from the way humans have expanded on Earth. Historically, when people moved into new regions, they could often use local ecosystems directly. Rivers, wood, animals, plants, soil, air, rain, sunlight, stone, metal ores. Mars provides raw materials, but almost none of them are immediately usable for human life without heavy processing. There are no trees to cut, no animals to hunt, no rivers to drink from, no open air to breathe, no fields to plant, no natural shelter that solves everything. Even if water ice exists nearby, it must be located, excavated, melted or processed, purified, stored, and protected from freezing or loss. Even if carbon dioxide can be used, it must be processed with machines. Even if Martian soil contains useful minerals, it must be collected, refined, and turned into something practical. The first colonists would not be living off the land the way pioneers did on Earth. They would be living off machines that transform the land. That difference is enormous. Mars is not generous. It is possible, but it is not generous, and the early colony would need to respect that. This brings us to site selection. Where should humans build the first serious settlement? The answer is not simple. A good site needs safe landing conditions. It needs access to water ice. It needs enough sunlight if solar energy is used. It needs manageable temperatures. It needs interesting science. It needs communication access. It needs terrain that rovers can cross. It may need natural protection or nearby geological features that help with shielding. But Mars rarely offers everything in one perfect place. Some areas may have better access to ice but colder conditions. Some areas may be easier to land in but less useful for resources. Some regions may be scientifically interesting but dangerous or difficult to reach. A site that is good for exploration may not be best for settlement. A site that is good for settlement may not be the most exciting scientifically. This creates tension between science, survival, and expansion. If the goal is a short mission, the landing site can be chosen for scientific value and safety. If the goal is a colony, resources become more important. Especially water. Water is not only for drinking. It can be split into hydrogen and oxygen. It can support agriculture. It can help with radiation shielding. It can be used in industry. It can become part of fuel production. It can regulate life support systems. A Mars base without reliable water access remains heavily dependent on Earth. So the search for usable water is really the search for independence. But extracting water on Mars would not be simple. If ice is buried under soil, the colony needs excavation equipment. If the ice is mixed with dust and salts, it needs purification. If temperatures are extreme, equipment must be protected. If the site is too far from the habitat, transportation becomes difficult. If extraction systems fail, the colony faces immediate pressure. Water on Mars is hope, but it is not automatically survival. Then there is the question of building. Early habitats may be sent from Earth as modules, inflatable structures, rigid pressure vessels, landed spacecraft converted into living space, underground shelters, modules covered with Martian soil. Each option has advantages and problems. A rigid module is strong but heavy. An inflatable structure may offer more volume for less mass, but it needs protection. Buried habitats provide radiation shielding, but excavation is hard. Lava tubes may offer natural protection, but they must be explored, secured, accessed, and adapted. Using Martian material for construction could reduce the need to import everything, but it requires machinery and proof that the materials will perform reliably. A future city might use local bricks, sintered regolith, 3D printed structures, metal extracted from the ground, or underground chambers. But the first base must start much simpler. The first priority is not elegance. It is pressure integrity. thermal control, radiation protection, reliability, repairability, and this creates a different aesthetic from science fiction. A real Mars base may be covered in dust. Cables may run between modules. Equipment may be stored outside in organized clusters. Airlocks may be reinforced. Solar arrays may spread across the terrain. Rovers may follow marked paths. Storage tanks may sit behind protective barriers. Habitats may be partly buried, not proudly exposed. It may look less like a shining city and more like a survival camp built by extremely careful engineers. But that rough beginning is how civilization often starts. The first settlements are rarely beautiful. They are functional. They are practical. They exist because people need shelter before they can build culture. Mars will be no different. Before there are schools, gardens, public spaces, art, music halls, or large communities, there must be oxygen systems that do not fail. Before there are children looking at the Martian sunset from protected windows, there must be pressure vessels, recycling loops, power grids, and emergency shelters. Before Mars becomes a home, it must become survivable. And survivability requires discipline. A Mars colony cannot afford casual habits. Doors must be sealed correctly. Tools must be returned. Airlocks must be operated properly. Dust must be controlled. Systems must be logged. Repairs must be documented. Health must be monitored. Waste must be tracked. Food must be rationed carefully when necessary. Every person must understand that the environment outside does not allow carelessness. This could shape the culture of Mars. The first Martian society, if it forms, may be extremely procedural. Checklists, training, shared responsibilities, emergency drills, strict maintenance, careful resource accounting. A mistake that would be minor on Earth could put everyone at risk. This means Mars colonists would need not only intelligence, but temperament. They would need patience, calm under pressure, cooperation, honesty, the ability to live in close quarters, the ability to follow procedures, the ability to admit problems early. A colony cannot function if people hide mistakes. If a system is failing, everyone needs to know. If a person is struggling mentally, the group needs support systems. If supplies are lower than expected, planning must change. Mars demands transparency because the planet punishes denial. This human side may be one of the hardest parts to engineer. Machines can be tested, materials can be measured, power systems can be modelled. But communities are alive. People disagree. People become tired. People miss home. People experience fear. People develop relationships, conflicts, loyalties, frustrations, hopes, and grief. A Mars colony would be a social experiment as much as a technological project. Who leads? How are decisions made? What happens when Earth and Mars disagree? Does mission control have authority, or does the settlement govern itself? If communication delays make real-time control impossible, local leadership becomes necessary. Over time, this becomes even more important. A small base may follow Earth-based command structures, but a growing settlement may develop its own needs, values, and priorities. The farther Mars moves from being an outpost to being a society, the more governance matters. This is another hidden barrier to colonization. It is not enough to send people. They must be able to live together. They must be able to decide together. They must be able to survive crises without tearing the community apart. In that sense, Mars tests not only our rockets, but our maturity. Can humans cooperate under extreme conditions? Can we build systems that are fair and stable? Can we handle scarcity without chaos? Can we plan beyond short-term excitement? Can we protect life on a world where life is fragile? These questions are not separate from colonization. They are at its center. Because every Mars habitat is also a human community, and every community needs trust. Trust may become as important as oxygen. Trust that the engineer checked the system. Trust that the doctor is honest. Trust that the commander listens. Trust that the farmer reports problems. Trust that Earth will send support. Trust that the group will protect one another. Without trust, Mars becomes unbearable. With trust, even a brutal world becomes more survivable. This is why the first colonists would likely be selected not only for skill, but for character. Not heroes in the dramatic sense, not reckless adventurers, but disciplined, emotionally stable, cooperative people who can live inside pressure and still make careful decisions. The romantic image of Mars colonization often focuses on boldness, but the real trait may be steadiness, the ability to do boring tasks perfectly, the ability to maintain systems day after day, the ability to stay calm when nothing is easy, the ability to accept that the planet will not reward impatience. Mars does not care about confidence, it only responds to preparation. And preparation must begin far earlier than the first human footprint. To colonize Mars, humanity needs a sequence. First, robotic scouts, then resource mapping, then landing tests, then cargo delivery, then power deployment, then life support demonstrations, then local oxygen production, then surface mobility, then short human missions, then longer stays, then infrastructure expansion, then partial self-sufficiency, then permanent presence. Each step depends on the previous one. Skipping steps may make a story exciting, but reality is less forgiving. This does not mean colonization is impossible. It means it is a long process. Maybe longer than the public expects. Maybe less glamorous than the videos suggest. Maybe more like building a civilization one system at a time. The problem is that human excitement often moves faster than infrastructure. People want cities. But before cities, there must be plumbing. People want domes. But before domes, there must be pressure control. People want forests. But before forests, there must be soil chemistry, water cycles, nutrient recycling, and controlled ecosystems. People want independence. But before independence, there must be manufacturing. Mars colonization is not a single event, it is a staircase, and every step is expensive, dangerous, and technically demanding. One of the most important early steps is the return mission. Before humans can safely land, many planners want confidence that they can leave. Getting to Mars is only half the journey. Launching from Mars requires fuel, engines, a launch vehicle, guidance systems, and orbital rendezvous or direct return capability. Bringing all the return fuel from Earth would be extremely heavy. That is why producing fuel on Mars is so attractive. But if the return fuel is made on Mars, the system that makes it must work before the crew depends on it. Imagine astronauts landing and discovering that the fuel production plant failed. That would be unacceptable. So the equipment may need to arrive first, operate automatically, fill tanks, and prove success before humans launch. Again, machines before people. Proof before trust. Mars forces caution, and this caution may conflict with public expectations. A slow, careful program may look less exciting than bold promises, but on Mars, slow can be wise. The planet gives no bonus for speed, it rewards reliability. The first successful settlement may not come from the fastest plan, but from the most patient one. The one that builds redundancy. The one that tests systems. The one that learns from robotic missions. The one that understands that a colony is not created by landing people, but by sustaining them. This is the difference between exploration and colonization. Exploration can accept temporary risk for a temporary mission. Colonization must create ongoing stability. Exploration can bring supplies and leave. Colonization must produce, recycle, repair, and grow. Exploration asks, can we get there? Colonization asks, can we stay? And staying is the harder question. Mars may be reachable within the imagination of modern technology, but staying there permanently requires turning an alien desert into a controlled human ecosystem. Not for days, not for weeks, but continuously, through dust storms, equipment failures, medical problems, political changes on Earth, funding cycles, launch delays, psychological stress, generational uncertainty. The colony must survive not only Mars, but human inconsistency. This may be one of the most underestimated obstacles. A Mars colony would depend on long-term commitment from Earth, especially in its early stages. But human societies change priorities. Governments change. Companies change. Economies shift. Public interest rises and falls. A major accident could reduce support. A financial crisis could delay missions. A political conflict could interrupt cooperation. If Mars depends entirely on Earth for decades, then the colony is vulnerable not only to Martian hazards, but to Earth's instability. This means true colonization requires more than technology. It requires commitment across generations. The willingness to continue when the first excitement fades. The willingness to fund maintenance, not just launch events. The willingness to support people after the cameras stop watching. The first Mars settlers would be depending on promises made across millions of kilometers. Promises must be kept. Because on Mars, abandoned infrastructure can become a graveyard of failed ambition. Empty habitats, silent rovers, solar panels buried in dust, half-built systems waiting for supplies that never come. This is a possible future too. Mars may not only test our ability to go, it may test our ability to continue caring. And that is why the question of colonizing Mars is so much deeper than it appears. It is not only about rockets, it is about responsibility. If we send people to Mars, we are responsible for them. If we build a settlement, we are responsible for its survival. If children are ever born there, the responsibility becomes even greater. A temporary mission can end. A colony becomes a moral commitment. You cannot treat human lives as a publicity project. You cannot build a world on excitement alone. Mars demands seriousness, and perhaps that seriousness is exactly what makes the dream powerful. Because if humanity ever does build a lasting presence there, it will mean we solve not one problem, but many. We learned how to cross space regularly. We learned how to land heavy cargo. We learned how to live with limited resources. We learned how to produce essentials from an alien planet. We learned how to manage closed ecosystems. We learned how to keep people healthy far from Earth. We learned how to cooperate under pressure. We learned how to think beyond one generation. A real Mars colony would be one of the greatest achievements in human history. Not because Mars is easy, but because it is not. Not because the planet welcomes us, but because it does not. Every light glowing in a Martian habitat would represent thousands of solved problems. Every breath taken inside the settlement would depend on engineering, planning, and discipline. Every plant growing under artificial lights would be a small rebellion against the deadness of the surface. Every repaired machine would be a victory over distance. Every new module would mean the human foothold had become slightly stronger. This is the real drama of Mars. Not explosions, not battles, not flags, but persistence. A small group of humans trying to make life continue in a place where life has no natural support. And if they succeed, the first colony may not look grand from the outside. It may look small, fragile, half-buried, surrounded by dust. But inside, it would contain something extraordinary. Warm air, liquid water, living plants, human voices, machines working through the cold night, a tiny pocket of Earth maintained by intelligence on another world. That is what we are really talking about when we talk about Mars colonization. Not fantasy cities, not effortless expansion, but the creation of a fragile island of life in a planetary desert. And to build that island, humanity must first solve the hardest problem of all: how to make survival reliable when failure is always nearby. The hardest part of colonizing Mars may not be building the first base. It may be what comes after. Because once humans survive the first landing, once the first habitat is pressurized, Once the first machines begin producing air, water, heat and power, the story does not become simple. It becomes more complicated. A first mission can be planned like an expedition. A colony cannot. An expedition has an ending. A colony has to become a beginning. That difference changes everything. The first people on Mars may arrive with carefully designed equipment, trained crews, emergency plans, and support teams on Earth watching every move. Every hour of the mission may be scheduled. Every system may have a checklist. Every major activity may be rehearsed before launch. But if Mars is ever going to become a true human home, life there cannot remain a temporary mission forever. People cannot live permanently inside an expedition. At some point, Mars would need routine, normal days, work schedules, rest, education, repairs, food production, medical care, construction, arguments, celebrations, boredom, loss, hope. A settlement becomes real when it stops being only a project and starts becoming a society. And that is where Mars becomes even more brutal. Because building a society on Mars is not the same as building one on Earth. On Earth, human communities grew inside a living planet. Even in harsh deserts, frozen regions, mountains and islands, people were still surrounded by breathable air, familiar gravity, biological cycles, and natural systems that could support life in some form. Mars gives none of that. A Martian society would have to create its own environment before it could create its own culture. Every street, if streets exist, would be sealed or protected. Every farm would be artificial. Every home would be part of a life support network. Every public space would exist because engineers made it possible. Every child, if children are ever born there, would grow up inside walls designed to keep the planet out. That single fact changes the meaning of home. On Earth, a home protects you from weather. On Mars, a home protects you from the planet itself. And this creates a strange psychological challenge. Can people feel truly at home in a place where the outside world is always dangerous? Can a settlement feel natural when everything about it is controlled? Can a child born on Mars look through thick windows at a red desert and feel belonging, even though stepping outside without protection would be impossible? These questions may sound philosophical, but they matter. A colony is not only a machine for survival, it is a place where humans must want to continue living. If Mars feels only like a prison, colonization fails emotionally, even if it succeeds technically. This is why the design of a future Mars settlement would need to go far beyond engineering. It would need beauty. It would need colour. It would need sound. It would need spaces where people can gather. It would need private areas where people can be alone. It would need rituals, art, music, stories, education, and reasons to wake up each morning besides maintenance. Survival keeps the body alive. Meaning keeps a community alive. The first habitats may be cramped and practical, but over time, if the settlement grows, people will demand more than oxygen. They will want gardens. They will want windows. They will want rooms that do not feel like laboratories. They will want places where children can play safely. They will want walls that are not only functional, but comforting. They will want some connection to Earth, but also a new identity of their own. A Martian culture, if it ever emerges, may begin in small details. The way people greet each other after a surface walk, the way they celebrate the arrival of a supply ship, the way they mark the anniversary of the first landing, the way they name habitats, corridors, greenhouses and rovers, the way they talk about Earth, the way they describe the red sky, the way they teach children what oceans are. That last idea is especially powerful. Imagine a child on Mars learning about Earth's oceans from videos, blue water stretching to the horizon, rain falling naturally from clouds, forests moving in wind, animals living outside without suits. To that child, Earth might feel almost mythical, a planet where you can walk outside and breathe, a planet where water falls from the sky, a planet where the horizon is alive. For us, Earth is normal. For a future Martian-born human, Earth may be astonishing. This reverses the way we think about Mars. Today, Mars is the alien world. In the distant future, Earth may become the strange paradise described in stories. But before that future can exist, one major question must be answered. Can humans reproduce and develop normally on Mars? This is one of the least understood parts of colonization. It is easy to imagine adults traveling to Mars, living in habitats, working in suits, and operating machines. But a permanent civilization requires generations. It requires children. It requires growth, development, health, education, and long-term stability. Mars' gravity is weaker than Earth's. We do not know how pregnancy, birth, childhood development, bone growth, muscle development, balance, circulation, and immune function would behave over a full lifetime in that gravity. This is not a small gap in knowledge. It is central. A settlement can be occupied by rotating crews even if long-term biology is uncertain. A civilization cannot. If human bodies cannot develop safely under Martian gravity, then Mars may remain an outpost rather than a true second home. Solutions might be imagined. Artificial gravity habitats, rotating living spaces, medical interventions, periodic travel to higher gravity environments, genetic or biological adaptation over very long timescales. But these are not simple answers. They introduce new costs, new risks, and new ethical questions. Would children born on Mars be able to visit Earth? If their bodies developed under lower gravity, Earth's gravity might feel heavy and difficult. Would they belong biologically to Mars more than Earth? Would they be trapped on the planet of their birth because returning to Earth would be dangerous or uncomfortable? A colony that begins as a human expansion could eventually create a new kind of human separation. Earth humans and Mars humans. Same origin. Different environments. Different bodies, perhaps. Different cultures. Different needs. This is where colonization becomes more than technology. It becomes history. If humans settle Mars permanently, we may be creating the first branch of humanity that grows under another sky. That possibility is extraordinary. But it is also serious, because every decision made in the early colony could shape generations. Where the settlement is built, how it is governed, how resources are shared, how risks are accepted, how children are protected, how connection with Earth is maintained, how independence is handled. These are not details, they are foundations. And foundations matter more when the environment is unforgiving. On Earth, a badly organised society can still rely on the planet's basic support systems. People can leave, move, trade, rebuild, adapt, or escape in many directions. On Mars, escape is limited. If the settlement is poorly governed, people cannot simply walk away and start a new town over the hill. Every community is tied to infrastructure. Air, water, power, food and shelter are centralized by necessity. This creates a political challenge. Who controls life support? Who owns the habitats? Who decides who gets oxygen, water, food, medical care, work assignments, and space? On Earth, politics can sometimes feel abstract. On Mars, politics becomes physical. A decision is not only a law. It may determine whether a system is repaired, whether a greenhouse receives power, whether a new module is built, or whether a risky expedition is allowed. This could create tension between Earth and Mars. At first, Earth would likely fund, build, and supply the settlement. That gives Earth enormous influence. Governments, companies, space agencies, or private investors may all want control. But people living on Mars will experience risks directly. They will know the machines, they will breathe the recycled air, they will understand the local dangers. They may eventually argue that decisions about Mars must be made on Mars. This is a familiar pattern in human history. Distant settlements often develop different priorities from the powers that created them. But Mars adds a new layer. The delay in communication makes direct control difficult. The danger of the environment makes local decision-making essential, and the cost of survival makes dependency unavoidable, at least at first. So a future Mars settlement may exist in tension, dependent on Earth but needing autonomy, funded by Earth but shaped by Martian reality, part of humanity but slowly developing its own identity. This may become one of the great questions of the future. Will Mars be a research outpost? A company town? An international settlement? A scientific preserve? A stepping stone to the asteroid belt? A backup for civilization? A new society? Each answer leads to a different kind of Mars. If Mars becomes primarily a commercial project, then profit may shape decisions. If it becomes a scientific project, preservation and research may dominate. If it becomes a national project, politics and competition may influence it. If it becomes a shared human project, cooperation becomes essential but difficult. The planet itself does not choose. Humans choose. And those choices may matter as much as rockets, because a Mars colony built with the wrong priorities could become dangerous even if the technology works. A settlement that cuts safety margins to save money is dangerous. A settlement that hides problems to protect reputation is dangerous. A settlement that treats workers as disposable is dangerous. A settlement that expands faster than its life support systems can handle is dangerous. A settlement that ignores mental health is dangerous. Mars punishes arrogance. It rewards patience, honesty, and redundancy. This may be the central lesson of the Red Planet. Mars is not a place where humanity can pretend to be stronger than nature. It is a place where every weakness becomes visible. If a system is badly designed, Mars exposes it. If leadership is careless, Mars exposes it. If planning is unrealistic, Mars exposes it. If people are unprepared, Mars exposes it. The planet does not need to attack, it simply waits. Cold, dry, silent, and indifferent. This is why the dream of colonization must be separated from the fantasy of conquest. Humans will not conquer Mars in any simple sense. At most, we may negotiate with it. We may learn its rhythms. We may build carefully around its hazards. We may use its resources in limited ways. We may create protected environments on its surface. But Mars will remain Mars. Even if humans live there for centuries, the outside world will still be hostile. Even if settlements grow, they will still depend on barriers between life and environment. Even if technology improves, the planet will not become gentle quickly. This brings us to one of the biggest myths about Mars. Terraforming. The idea is powerful. Transform Mars into a second Earth. Thicken the atmosphere. Warm the planet. Melt ice. Create oceans. Plant life. Build a breathable world. It is one of the grandest dreams in space imagination. But in reality, terraforming Mars would be far beyond anything humans can currently do. The atmosphere is thin. The planet is cold. It lacks a strong global magnetic shield. Much of the carbon dioxide needed for a thicker atmosphere may not be available in an easy or sufficient form. Water is limited compared to Earth, and even if humans could warm the planet, maintaining a new atmosphere over long timescales would be an enormous challenge. Terraforming is not building a city, it is changing an entire planet. That is a task so large that it almost becomes mythological. Maybe a civilization thousands of years more advanced could attempt partial transformation. Maybe future technology could create regional habitats, artificial magnetospheres, giant orbital mirrors, or enclosed ecosystems on a massive scale. But for the foreseeable future, Mars colonization will not mean walking outside under open skies. It will mean living in controlled environments. This does not make Mars less important. It makes the achievement more realistic. The first goal is not to make Mars into Earth. The first goal is to keep humans alive there. Then to make them safer, then healthier, then more independent, then more capable of staying. Civilization does not begin with paradise. It begins with stability. And stability on Mars will be hard won. One of the most important steps towards stability is recycling. On Earth, waste can be hidden, thrown away, buried, washed downstream. Exported, ignored, Mars has no away. Everything remains part of the settlement's closed system. Waste becomes a resource. Water must be recovered. Air must be cleaned. Organic matter must be reused. Packaging must be minimized. Materials must be repaired, repurposed, or recycled. The colony must learn to treat every resource as precious. This could make Mars a strange kind of teacher. A Martian settlement may become one of the most efficient human communities ever created, not because people are naturally disciplined, but because the environment forces them to be. Nothing can be wasted casually. A leak matters. A broken tool matters. Food scraps matter. Heat loss matters. Water vapor matters. Even dust carried inside matters. Mars could teach humans how fragile life support really is. On Earth, we often forget that we also live inside a life support system. The atmosphere, oceans, forests, soil, and climate are not background details. They are the systems that make us possible. Mars makes this obvious because the systems must be built manually. A Mars colony is like a miniature Earth constructed inside walls. Air cycles, water cycles, nutrient cycles, energy flows, waste recovery, temperature regulation, biological support. Everything Earth does naturally must be recreated artificially, at least in part. This may change how settlers think about Earth. They may understand our home planet more deeply than many people who never leave it. Because when you have to build life support from scratch, you realize how miraculous natural life support truly is. Mars may not make us love Earth less. It may make us love Earth more. That is one of the ironies of space exploration. The farther we go, the more precious home becomes. Astronauts often describe Earth as fragile when seen from space. A blue world wrapped in a thin atmosphere, no borders visible, no obvious division between nations, just a planet alive in darkness. Mars would intensify that feeling. From Mars, Earth is not a world beneath your feet. It is a distant light, a memory, a source of messages, a place you may never return to. For the first settlers, Earth would be both home and sky object. That emotional distance could be difficult. Some people may feel inspired by it. Others may feel grief. A colony must be prepared for both. The psychological challenge of Mars will not be solved simply by choosing brave people. Bravery helps during crisis. But long-term isolation requires more than bravery. It requires emotional design. Habitats must support mental health. Schedules must include rest. Communication with Earth must be meaningful. Communities must manage conflict. People must have purpose. The environment must include beauty. There must be ways to mark time, celebrate achievements, mourn losses, and feel human. A Mars settlement that ignores the inner life of its people may survive technically while failing socially. This is why art may be as important as engineering in the long run. Not at the first moment of survival, perhaps, but eventually. People need symbols, they need stories, they need music, they need shared identity. They need to feel that they are not merely maintaining machines until the next supply ship arrives. They need to believe they are building something worth the difficulty. The first Martian songs, paintings, poems, and stories may emerge from that need. They may speak of red dust, distant Earth, weak sunlight, humming machines, and the strange silence outside the walls. They may sound different from art made on Earth, because they would come from a different relationship with environment. On Earth, nature surrounds culture. On Mars, culture may surround nature, holding it outside the habitat walls. That inversion could shape everything. Even architecture would change. A Martian building is not just a building, it is a boundary between life and death. That gives architecture a deeper responsibility. How do you create spaces that are safe without making people feel trapped? How do you create openness without exposing people to radiation? How do you create community without eliminating privacy? How do you create beauty when every window and wall must obey engineering limits? Maybe future Martian architecture will use underground chambers with artificial skies. Maybe habitats will include interior gardens lit by carefully tuned lamps. Maybe public spaces will use curved walls, warm colours, water features, and soundscapes from Earth. Maybe settlers will build memory rooms containing images, smells, and sounds from oceans, forests, and rain. Maybe the first luxury on Mars will not be wealth. Maybe it will be a room with plants. A room where the air smells alive. That may sound small, but on Mars it could be priceless. The value of ordinary Earth experiences would change. Fresh fruit might feel extraordinary. A cup of water might carry emotional weight. A patch of green might become a spiritual place. The sound of wind through trees, played through speakers, might make people cry, because Mars teaches scarcity, and scarcity changes meaning. This is another reason colonization cannot be understood only through technology. It changes values. What is valuable on Mars? Not gold, not land in the ordinary sense, not luxury cars, not oceanside property. The most valuable things may be pressure volume, clean water, reliable energy, fertile growing space, spare parts, medical capability, and trust. A culture built around those values would be very different from many Earth cultures. Status might come from competence, from reliability, from the ability to repair systems, from the ability to grow food, from the ability to keep others calm. A person who can fix a failing oxygen system may be more important than a person with money. A farmer engineer may be a hero. A maintenance worker may be essential to civilization. Mars could reorder human priorities. That might be one of its hidden gifts. But only if the settlement survives long enough. Survival remains the foundation beneath every dream, and survival will always depend on the weakest links. Life support must not fail. Power must not fail. Water must not fail. Food systems must not fail completely. Medical systems must be ready. Communication must remain functional. Structures must hold pressure. People must cooperate. The colony must prepare for dust storms, equipment failures, injuries, launch delays, supply shortages, and unexpected discoveries. Unexpected discoveries matter too. Mars may still hold scientific secrets. There may be ancient organic chemistry preserved in rocks. There may be underground ice records of past climates. There may be places where liquid water existed for long periods in the distant past. There may even be evidence of ancient microbial life, if Mars ever had it. This creates another serious question. What if Mars has life? Not forests or animals, but microbial life, perhaps underground, perhaps rare, perhaps ancient, perhaps barely surviving. If humans colonize Mars aggressively, we could contaminate it. Earth microbes could spread from habitats, waste systems, suits, landers, or drilling equipment. Even if survival is difficult, contamination risk cannot be ignored. This matters scientifically and ethically. If Mars has native life, it may represent a second origin of biology in our solar system. That would be one of the greatest discoveries in history. Destroying or confusing that evidence before understanding it would be a tragedy. So, colonization must balance human expansion with planetary protection. Where do we build? Where do we drill? How do we prevent contamination? How do we study Mars without damaging what we came to understand? If life exists there, do we have the right to transform the planet? These questions could become deeply controversial. Some people would argue that human survival comes first. Others would argue that an independent Martian biosphere, even microbial, has immense value and should be protected. This debate may shape the future of Mars more than many people expect, because Mars is not just empty real estate, it is a planet with history, a world that may preserve clues about early solar system conditions, ancient water, climate change, planetary evolution, and perhaps life itself. To colonize Mars without humility would be dangerous. We may not fully understand what we are entering. This is another way Mars is brutal. It challenges our assumptions. We see a barren planet and assume it is available, but science teaches patience. A dead-looking world may still hold deep secrets. A dry valley may contain ancient evidence. A buried ice deposit may preserve a climate record. A subsurface region may be chemically active. The first colonists would not only be settlers, they would be guardians of a planetary archive. That responsibility is enormous, and it connects to a larger question. Why colonize Mars at all? The common answers are familiar. To ensure humanity's survival. To explore, to inspire, to develop technology, to access resources, to become a multi-planet species, to satisfy curiosity, to continue the human story outward. Each answer has power, but each answer also needs honesty. Mars is not an easy backup planet. If Earth was severely damaged, Mars would not be a comfortable refuge for billions. It cannot quickly replace Earth. It cannot support human life without technology. It would take immense effort to support even small populations. Protecting Earth remains far easier than making Mars livable. This is important. Mars should not become an excuse to neglect our home. A second world does not make the first world disposable. If anything, Mars proves how rare and valuable Earth is. The dream of Mars should deepen environmental responsibility, not weaken it. Because once we understand what it takes to keep a few humans alive on Mars, we better understand what Earth provides freely every second. Air, water, warmth, pressure, food webs, climate balance, radiation protection, living soil, a biosphere. Earth is not easily replaced. Mars may become an extension of human civilization, but Earth remains the source, the beginning, the only world we know that naturally carries human life. This truth should remain at the center of every Mars dream. Colonizing Mars is not about escaping responsibility. It is about expanding responsibility. Responsibility to settlers, responsibility to science, responsibility to the planet itself, responsibility to Earth, responsibility to future generations who may live with the consequences of decisions made today. That makes Mars one of the greatest tests humanity could face, not simply a test of intelligence, but a test of wisdom. Can we go without destroying what we study? Can we settle without repeating the worst patterns of history? Can we build communities that value life more than spectacle? Can we create systems that last beyond the first wave of excitement? Can we treat another planet not as a trophy, but as a place deserving care? These questions may sound idealistic, but on Mars, ideals become practical. A selfish colony may fail. A careless colony may fail. A divided colony may fail. A dishonest colony may fail. Survival requires cooperation. Cooperation requires trust. Trust requires values. So the future of Mars depends not only on engines, fuel, and habitats. It depends on what kind of civilization chooses to go there. If we bring only ambition, Mars may break us. If we bring patience, discipline, humility, and care, then perhaps we can build something extraordinary. Not a second Earth. Not at first. Maybe not ever. But a second home of a different kind. A place where human life survives because it is protected, intentional, and deeply aware of its fragility. A place where every breath is a reminder of engineering. Every plant is a reminder of Earth. Every sunrise is a reminder that humans cross space to stand under another sky. The dream remains powerful, but the dream must be honest. Mars is not waiting with open arms. Mars is waiting with cold ground, thin air, radiation, dust, silence, and distance. It will not become easy because we want it enough. It will become possible only if we respect how hard it truly is. And perhaps That is the real answer to what is preventing us from colonizing Mars. It is not that one wall stands in our way. It is that Mars asks humanity to become better at almost everything at once. Better engineers, better planners, better doctors, better farmers, better builders, better leaders, better communities, better caretakers, better long-term thinkers. The Red Planet does not only challenge our machines, it challenges our civilization. And maybe that is why we keep looking at it. Because somewhere beyond the danger, beyond the dust, beyond the cold and silence, Mars represents a question. Can humanity grow beyond Earth without forgetting what Earth taught us? Can we carry life carefully into a place that has none? Can we build not just a base, but a future? The answer is not written yet. It will not be written by dreams alone. It will be written by every launch, every landing, every repaired system, every protected greenhouse, every difficult decision, every person who chooses patience over pride. Mars is brutal, but maybe that brutality is exactly why it matters. Because if humanity can learn to survive there, not recklessly, not selfishly, but wisely, then we will have learned something profound. Not only about Mars, but about ourselves. There is one final misunderstanding about Mars that must be removed. A human footprint is not colonization. A flag is not colonization. A temporary habitat is not colonization. Even a crew living on Mars for several years would not automatically mean that humanity had created a permanent second world. Colonization begins only when the settlement can survive more than a single mission. It begins when people can remain through missed launch windows, damaged equipment, political changes on Earth, interrupted shipments, medical emergencies, and the slow passage of time. It begins when Mars stops being a destination and becomes a place where human history can continue. That is a much higher standard. And reaching it may require generations. The first human mission would probably be remembered as one of the greatest achievements in history. Millions of people would watch the landing. The first steps would be broadcast across Earth. The astronauts would describe the strange colour of the sky, the low gravity, the silence, and the sight of another planet beneath their boots. For a few days, Mars would dominate every screen. But the real test would begin after the attention moved elsewhere. The cameras would no longer show only historic moments. They would show maintenance, inventory checks, equipment inspections, medical examinations, dust removal, software updates, air filter replacements, power management, crop monitoring, routine repairs. That is where Mars would either become a home or remain only an extraordinary visit. Human civilization is not built from dramatic moments alone. It is built from ordinary days that continue without collapse. A Mars settlement must be able to produce ordinary days in an extraordinary environment. That may be harder than the landing itself. On Earth, ordinary life is supported by systems so large that individuals barely notice them. Farms produce food far away. Power stations operate beyond view. Factories create replacement parts. Hospitals contain specialists. Roads connect communities. Water treatment plants run continuously. Global networks move materials around the planet. Mars would begin with almost none of this depth. Its first settlement would be narrow. A limited number of machines, a limited number of people, a limited number of skills, a limited number of backups. This makes the colony vulnerable to something engineers call a common failure. Imagine that several important systems depend on the same type of electronic controller. If that component develops a design fault, multiple systems could fail together. Imagine that all food production depends on one greenhouse complex. A single environmental problem could threaten the entire harvest. Imagine that the settlement relies on one water source. If extraction stops, every part of the colony feels the pressure. Redundancy must therefore mean more than owning a second copy of the same machine. The settlement needs different methods, different locations, different designs, different ways to solve the same problem: solar power and nuclear power, ice extraction and stored water. Multiple greenhouses separated from one another, habitats divided into pressure zones, independent emergency shelters, several rovers rather than one central vehicle. A colony built as one large connected structure may look efficient, but it could also allow one accident to affect everything. A stronger settlement may resemble a network of small protected islands, each capable of supporting life for a limited period. Each connected, but not completely dependent on every other section. This would make Mars architecture very different from the shining single domes often shown in fiction. The first true settlement might be spread across the surface. Buried living modules, separate energy stations, storage shelters, greenhouse units, manufacturing areas, medical spaces, emergency refuges, vehicles moving between them along prepared routes. The settlement would be designed around the assumption that something will eventually fail, not because the engineers were pessimistic, because permanent survival requires realism. Earth systems fail every day. Power lines break, pipes leak, computers crash, vehicles stop working, buildings are damaged. The difference is that Earth has enormous repair capacity. Mars would not. So every critical system must be designed not only to function, but to be understood and repaired by the people living beside it. This is a hidden problem in modern technology. Many machines are extremely advanced, but difficult to repair without specialized factories, software, tools, and supply chains. That model cannot work indefinitely on Mars. A settlement filled with sealed devices that nobody can open would remain dangerously dependent on Earth. Mars technology may need to be simpler in certain ways. Modular, accessible, standardized, built with replaceable parts. Designed so that one component can serve several purposes. A machine that is slightly less efficient but easy to repair may be more valuable than a perfect machine that becomes useless after one failure. The colony would have to develop a culture of repair. Nothing important could be casually discarded. Broken equipment would become a source of materials. Old cables would be reused. Metal would be reshaped. Electronic parts would be recovered. Containers would serve new purposes. Vehicles might be rebuilt repeatedly until little of the original machine remained. Every object sent from Earth would carry value far beyond its price. A bolt is not just a bolt when the nearest replacement is millions of kilometers away. A sheet of metal is not waste. A damaged motor is not simply broken. It is copper, magnets, bearings, wire, knowledge, and possibility. The first Martians may become some of the most creative repair workers in human history. They would learn to see objects, not only for what they were designed to do, but for what else they could become. This flexibility would be essential during the long periods between supply missions, because Mars has another kind of season, not a season created by temperature, a season created by orbital position. There would be times when Earth and Mars were well placed for transportation. There would be times when they were badly placed. There would also be periods when communication could become difficult, because the Sun lies between the two planets. During these times, the colony would need to operate with greater independence. No constant advice. No immediate software support. No easy exchange of information. The settlement would experience periods when Earth felt more distant than usual. This could influence Martian culture. Supply arrivals might become major events. People could count months until the next ship. Children might gather to watch a bright object descend through the atmosphere. Families might wait for personal packages sent years earlier. Scientists might receive new equipment. Doctors might receive medicines. Engineers might receive the components they had been protecting for months. A cargo landing would be more than logistics. It would be contact with home. But a true colony cannot build its emotional and physical survival entirely around those arrivals. At some point, Mars must reduce the number of things that can only come from Earth. oxygen may be one of the first areas where independence becomes possible. The Martian atmosphere provides carbon dioxide that can be processed. Water can provide oxygen through chemical separation. A settlement could potentially generate breathable oxygen and store it. This would be a major achievement. But oxygen independence alone is not enough. Water independence would come next. Then perhaps construction material. Then basic fuel. Then a growing percentage of food. Then simple replacement parts. Then more complicated manufacturing. Every local capability removes one thread of dependency. Yet complete self-sufficiency is far more difficult than it sounds. A colony may produce oxygen while still depending on Earth for seals. It may grow vegetables while importing grains, oils, vitamins, and specialized nutrients. It may manufacture metal structures while importing computer chips. It may have excellent doctors while depending on Earth for medicines and advanced medical equipment. It may repair rovers while lacking the ability to produce certain batteries or sensors. Self-sufficiency is not one achievement. It is a ladder with thousands of steps. At the bottom are the basics: air, water, heat, power, shelter. Above them are food, clothing, tools, transport, and medicine. Higher still are electronics, advanced chemicals, scientific instruments, communication equipment, and industrial machines. A modern civilization depends on an astonishing number of materials and processes. Recreating even a small portion of them on Mars would require years of development. This is why the settlement may remain connected to Earth for a very long time. Dependence itself is not failure. The danger comes when the dependence is hidden. A responsible Mars program would need to know exactly which imported items could threaten the colony if shipments stopped. Every supply chain would need to be studied. How many years of medicine are stored? Which machines depend on rare components? Can local workshops replace them? How long can batteries remain useful? How many backup suits exist? Can precious seals be manufactured locally? Can food production survive without imported nutrients? Can medical teams operate without new supplies? These questions may determine whether the settlement is permanent or merely long-lasting. A colony that survives only while Earth remains interested is not fully secure. History shows that human priorities change. An economic crisis could reduce funding. A war could interrupt launches. A major accident could cause public support to collapse. A new government could abandon the program. A company could fail. A launch provider could experience technical problems. Mars settlers would live with the knowledge that events on another planet could shape their future. This may create pressure for independence much earlier than Earth expects. The colonists might begin by seeing themselves as representatives of nations or organizations. Over time, they may see themselves simply as Martians, not because they reject Earth, because their daily reality is different. Earth debates may feel distant when a settlement is deciding how much power can be given to a greenhouse during a dust storm. An instruction written in an office on Earth may seem unreasonable to the people who must carry it out on Mars. The communication delay reinforces this separation. Mars cannot be managed minute by minute from Earth. People on the surface must have authority. They must be trusted to make decisions. This raises a difficult question. Who has the right to live on Mars? Early missions would select people carefully. Health, training, emotional stability, technical ability, teamwork. But as the settlement grows, selection becomes more complicated. Will only scientists and engineers be allowed? Will wealthy individuals be able to buy places? Will governments choose citizens? Will companies choose workers? Will people sign contracts requiring years of service? Could someone born on Mars be controlled by an organization based on Earth? The first Martian society could inherit inequalities from Earth if these questions are ignored. A settlement where one company owns the habitat, the oxygen system, the food, the transport, and the communication network could place enormous power in a small number of hands. On Earth, a worker can leave a company. On Mars, Leaving may mean losing access to the environment that keeps you alive. This makes freedom a physical issue. Who controls the air? Who controls the doors? Who decides who may return to Earth? Who has access to communication? Who owns locally extracted water? Who owns the structures built by settlers? Mars law cannot be treated as an afterthought. The colony would need clear rights. The right to safety, the right to medical care, the right to communication, the right to participate in decisions, the right to report danger without punishment, the right to leave when transportation is available, perhaps even the right to basic life support resources regardless of employment. These ideas would need to be established before a crisis. During an emergency, power tends to concentrate. That may be necessary temporarily, but a permanent settlement cannot live forever under emergency rules. At first, strict command structures may be essential. A small crew facing immediate dangers needs fast decisions. But as the population grows, the system must change. A base of 12 people can operate like a mission. A settlement of hundreds requires institutions. A settlement of thousands requires law, education, public health, economic systems, and representation. Colonization is therefore not just the expansion of habitat volume, it is the expansion of social complexity. Mars cannot remain a camp forever. It must learn how to become a town. Then, perhaps a city. And cities need more than engineers. They need teachers, counselors, cooks, designers, artists, caregivers, researchers, administrators, technicians, children, older people. A community made only of highly trained astronauts might perform brilliantly for a mission, but a permanent society needs a wider range of human experience. This creates another transition. The first Mars inhabitants would be selected because they were unusually capable. Later generations would simply be born there. A child does not choose a planet. That changes the ethical responsibility of the colony. Adults may willingly accept extreme risk. Children cannot consent to the conditions of their birth. The settlement would therefore need to reach a very high level of safety before permanent families became responsible. Stable food, reliable medicine, protected living space, education, social support, long-term biological research, emergency plans, a realistic future. Bringing children into a settlement still dependent on fragile experimental systems would raise serious questions. This is one reason the move from base to civilization may be slow. Humans may reach Mars long before Mars becomes a place suitable for raising generations. The first decades could consist mainly of rotating crews, people arriving, staying for a limited period, and returning to Earth. Only after the settlement proves itself might permanent residence become realistic. This delay may disappoint those who imagine immediate colonization, but caution would be a sign of responsibility. Mars is not a place for experiments with lives that cannot choose the risk. Another difficult subject is death. A permanent community must prepare for the full human life cycle. Birth, illness, aging, death, early missions may try to select young and healthy crews, but no population remains young forever. Accidents can happen. Illness can appear. Medical emergencies cannot always be solved. A Mars settlement would need ways to care for people when treatment is limited. It would need cultural practices for loss. It would need to support families and communities after tragedy. It would need to decide how to handle remains in an environment where burial, cremation, and return to Earth are all complicated. These are not comfortable topics. But permanence requires honesty about them. A society becomes real when it can care for people through every stage of life, not only during moments of achievement. Medicine on Mars would therefore need to develop far beyond emergency first aid. The settlement would need surgery capability, dental care, mental health support, long-term disease management, rehabilitation, reproductive medicine, pharmaceutical production, medical imaging, laboratories, isolation areas, A population cannot remain healthy forever with a small box of supplies from Earth. Local medical production may become one of the hardest industrial goals. Some medicines are chemically complex, some require biological processes, some need refrigeration, some expire. The colony might use advanced manufacturing, cultured cells, automated laboratories, and carefully maintained chemical systems. Doctors may be supported by artificial intelligence and specialists on Earth, but the final decisions would often be local. When a patient cannot wait 30 minutes for a conversation, the medical team must act. Mars turns every profession into a frontier profession. Doctors become engineers. Engineers become emergency responders. Farmers become ecosystem managers. Teachers become cultural historians. Pilots become mechanics. Everyone carries more responsibility because there are fewer people to share it. This can create pride. It can also create exhaustion. Burnout may be a serious danger. In a small settlement, a highly skilled person cannot easily be replaced. If the only surgeon becomes ill, capability disappears. If the main power engineer is exhausted, the entire base may become vulnerable. The colony would need overlapping expertise. Several people trained for each important role. Education would not be optional. Every generation must understand the systems keeping it alive. Children growing up on Mars may learn pressure safety the way children on Earth learn road safety. They may study life support engineering as a basic subject. They may know how to recognize air leaks, power problems, crop disease, and radiation warnings. Technical literacy could become part of Martian identity. This would shape the culture deeply. On Earth, nature is usually experienced as something outside human control. On Mars, the immediate environment inside the habitat is deliberately created. Air composition is measured. Humidity is controlled. Water is tracked. Light is scheduled. Temperature is maintained. Food production is monitored. The boundary between society and environment becomes almost invisible. A political decision about power can change crop growth. A maintenance decision can affect air quality. A design choice can affect mental health. Everything connects. Mars teaches systems thinking because survival depends on understanding connections. This may produce a society less willing to ignore long-term consequences, or it may produce a society under constant pressure, focused only on immediate stability. The outcome would depend on how the settlement is designed. A colony that always operates near failure may become strict, fearful, and resistant to change. A colony with strong reserves may become more creative and open. Safety margins are therefore not only technical. They shape culture. Extra power means freedom to experiment. Extra food means freedom from constant anxiety. Extra habitat space means privacy. Extra water means gardens. Extra manufacturing capacity means art, research, and expansion. Surplus is what allows civilization to become more than survival. The first goal on Mars would be efficiency. The long-term goal would be abundance. Not wasteful abundance, resilient abundance. Enough oxygen that one broken machine does not create panic. Enough water that agriculture can expand. Enough power that people can pursue science, art, and personal projects. Enough space that families do not live permanently inside narrow corridors. A colony remains fragile until it creates reserves. This is another reason growth must be carefully controlled. Adding people increases capability. More hands, more skills, more creativity. But every new person also consumes resources. Air, food, water, energy, living space, medical capacity. Transportation. The settlement cannot expand simply because a ship can carry more passengers. Infrastructure must grow first. A responsible colony would need clear population limits. How many people can the food system support if one greenhouse fails? How many can the water system support during repairs? How many can fit inside emergency shelters? How many medical cases can the clinic handle? How many suits are available? Growth without capacity would be dangerous. This is where economic pressure may conflict with safety. A company may want more workers. A government may want a larger presence. A settlement may want more specialists. But Mars does not care about political ambition. The systems either support the population or they do not. Numbers cannot be negotiated with nature. This truth may create a different kind of leadership. The most respected leaders may be those willing to say no. No to expansion before the power grid is ready. No to a dangerous surface expedition. No to reducing reserves. No to promises that exceed reality. Mars rewards restraint. On Earth, leaders often gain attention through grand plans. On Mars, survival may depend on the leader who protects boring essentials. Filters, storage, maintenance, training, spare capacity. There will still be ambition. Humans will want to explore. Mars is a planet filled with enormous landscapes, canyons deeper than any on Earth, volcanoes higher than Earth's greatest mountains, ancient river channels, polar ice, cratered highlands, regions that may preserve evidence of past environments. A permanent settlement would become a base for exploration across the planet, but moving around Mars would remain difficult. Distances are large. Roads do not exist. Terrain can be dangerous. Dust can hide features. Communication may be limited. Rovers must carry life support or remain within rescue range. A journey hundreds of kilometers from the base would feel like an ocean voyage on early Earth. Explorers would need supplies, navigation, backup vehicles, emergency shelters, and a way to survive if they could not return quickly. This could eventually lead to the creation of multiple settlements, one near accessible ice, another near scientifically important terrain, another near useful minerals, another serving as a transportation center. A network of bases would make Mars more resilient. One settlement could help another. Supplies could move across the surface. Knowledge could be shared. Different regions could specialize. But multiple settlements also introduce politics. Competition, trade, different identities, different rules. Human history would begin again under new conditions. Will Martian settlements cooperate because survival requires it? Or will they repeat Earth's divisions? The answer depends on the choices made from the beginning. Mars offers no guarantee that humans become wiser simply because they travel farther. Technology changes location. It does not automatically change character. People will carry generosity and selfishness, courage and fear, cooperation and rivalry. The Red Planet will receive the whole human story, not only its best parts. This is why the values built into the first settlement matter. If the early culture celebrates honesty, shared responsibility, scientific thinking, and care for human life, those values may endure. If it celebrates secrecy, reckless expansion, and power without accountability, Mars could become dangerous for reasons unrelated to the environment. The planet is already hard enough. Humans should not add unnecessary brutality. There is also the question of economic purpose. Why would a permanent settlement continue to receive enormous support? Exploration and inspiration can justify early missions. A colony lasting centuries may need more. Some imagine mining valuable resources. Others imagine science, tourism, manufacturing, or serving as a transportation point for deeper space. But moving materials from Mars to Earth is expensive. Many resources available on Mars also exist elsewhere. A colony may not become profitable in the ordinary sense for a very long time. Its value could be strategic rather than financial. Scientific discovery, technological development, human survival knowledge, experience building closed ecosystems, experience managing life beyond Earth, cultural significance. These benefits are real, but difficult to measure in money. Humanity would need to decide whether creating a permanent presence on another planet is worth supporting even without immediate profit. That decision may determine the speed of colonization more than any rocket, We already possess many pieces of the required technology. We know how to send machines to Mars. We know how to live in space for months. We know how to recycle water and air. We know how to grow plants in controlled environments. We know how to operate robots on another planet. But turning these separate abilities into a reliable settlement requires scale, repetition, and commitment. The missing ingredient may not be a single invention. It may be sustained effort. Mars projects are often described through breakthroughs: a better engine, a larger rocket, a new habitat, but civilization is built through continuity. A launch every few years, improved landing systems, repeated cargo missions, long-duration surface tests, factories that keep producing equipment, teams that remain funded, lessons that are preserved rather than forgotten, one generation building on the work of another. This is slower than a dramatic leap. It is also more realistic. The first true Mars colony may emerge gradually. At first, one crew stays longer than previous crews. Then a second habitat is added. A greenhouse produces more food than expected. A local water system runs for years. A workshop creates its first useful metal component. A medical team performs a procedure that once required return to Earth. A child receives an education entirely on Mars. A settlement survives a missed supply window without crisis. One day, people may realize that Mars is no longer only a mission. It has crossed a threshold. Human life there can continue. That moment may not have a clear date. No single ceremony. No dramatic announcement. Civilization often grows quietly. A road is built. A room is added. A field is planted. A child is born. A community becomes permanent through accumulation. Mars may follow the same pattern. The most important day in Martian history may look ordinary while it happens. A technician repairs a pump using locally manufactured parts. A farmer harvests enough food to reduce imports. A teacher begins the first school year. A doctor trains a new generation of medical workers. A council makes a decision without waiting for Earth. Small events. Together, they create independence. But independence would not mean separation from humanity. Earth and Mars could remain deeply connected. Ideas, culture, science, and people moving between worlds. Each planet offering a different perspective. Earth, rich with life. Mars, shaped by deliberate survival. The relationship may resemble two branches of one civilization, different but connected. This future is possible. It is not guaranteed. Mars could remain a scientific outpost for centuries. Attempts at settlement could fail. Costs could remain too high. Health problems could prove more serious than expected. Political support could disappear. Technology could move in another direction. Humanity may choose the moon, orbital habitats, asteroids, or artificial space stations as easier places to expand. Mars is not destiny. It is an option, an extraordinary option. But the planet does not owe us a future. We must build one carefully. So what is actually preventing us from colonizing Mars? It is tempting to name one barrier: radiation, distance, cost, low gravity, food, landing difficulty, human psychology. But none alone explains the delay. The true barrier is integration. All essential systems must work together. A powerful rocket is useless without a safe landing system. A safe landing is useless without reliable life support. Life support is not enough without power. Power is not enough without repair capability. Repair is not enough without spare materials. Food production is not enough without water and nutrients. Medical equipment is not enough without trained people. Technology is not enough without stable leadership. Leadership is not enough without trust. Trust is not enough without long-term commitment. Colonizing Mars means solving an entire civilization at once, in miniature. That is why it has not happened yet. Not because humans lack imagination, Because Mars demands more than imagination. It demands systems that can survive isolation. It demands people who can cooperate under pressure. It demands governments and organizations willing to plan beyond short-term rewards. It demands technology designed for repair rather than replacement. It demands an honest understanding of risk. And perhaps most importantly, it demands respect for the difference between visiting a world and belonging to it. One day, a human may stand outside a Martian settlement at sunset. The sun will appear smaller than it does from Earth. The sky near it may glow blue while the wider horizon remains dusty and red. Behind the astronaut, buried habitats will shine with artificial light. A power station will operate across the plain. Green plants will grow inside protected rooms. Water will move through pipes extracted from ancient ice. Children may be sleeping beneath layers of shielding. Machines will hum through the cold evening, keeping a small community alive. Earth will be somewhere in the sky. Too distant to see as a world, close enough to remember. That astronaut may look across the empty landscape and understand what the settlement represents. Not the conquest of Mars, not the defeat of nature, not an easy escape from Earth. It represents cooperation. Thousands of years of human knowledge brought together in one place. Astronomy, medicine, agriculture, engineering, chemistry, psychology, architecture, law, education, all of it protecting life on a world where life cannot survive unassisted. The settlement would be fragile. But fragility does not make something unimportant. Earth itself is fragile when seen against the scale of space. A thin atmosphere, a narrow temperature range, a living surface surrounded by darkness. Mars may teach humanity to recognize that truth. Every breath inside a Martian habitat would be deliberate, every drop of water recovered, every calorie planned, every wall built for protection, every life dependent on systems people understand and maintain together. Perhaps living on Mars would make humanity more aware of what survival really means, not strength alone. Connection, balance, care, the recognition that no person survives independently from the systems and communities around them. Mars would make that dependence visible. It may be harsh. It may be exhausting. It may also create one of the strongest communities humans have ever built. Because on Mars, cooperation would not be an ideal discussed from a distance. It would be the atmosphere everyone shares. The dream of Mars will survive because it speaks to something ancient inside us. The desire to cross the horizon, to know what lies beyond the familiar, to build where nothing existed before, to leave something for the future. But the dream must mature. It must move beyond images of flags and glass cities, beyond promises of quick transformation, beyond the fantasy that one planet can replace another. Mars will not save humanity from every problem. It will create new problems. It will expose weaknesses. It will demand patience. It will cost more than expected. It will take longer than expected. And the first people who go may live harder lives than the people watching from Earth can fully understand. Yet difficulty does not make the goal meaningless. Some goals matter because they require humanity to grow. Mars asks us to think beyond one mission, beyond one company, beyond one nation, beyond one lifetime. It asks whether we can build something whose greatest results belong to future generations. That may be the most difficult challenge of all. Modern societies often struggle to plan for decades. Mars may require planning for centuries. The people who begin the work may never see a city. The people who build the first habitats may never see a self-sufficient settlement. The people who solve the first food systems may never see families living normal lives beneath the red sky. They would be building for others. This is how cathedrals were once built, how scientific knowledge grows, how forests are planted, how civilizations continue. One generation begins what another completes. Mars colonization, if it happens, will be that kind of project, a chain of effort extending across time. And perhaps that is the final answer. What is preventing us from colonizing Mars is not an impossible wall. it is the size of the responsibility. Mars requires humanity to commit to a future larger than individual ambition, to value maintenance as much as discovery, to protect people after the excitement fades, to build systems that can be repaired by those who depend on them, to create laws before power becomes dangerous, to study biology before raising generations in an unknown gravity, to develop independence without abandoning connection, to carry life to another world without treating that world carelessly. We may eventually do all of this. Rockets will improve, landing systems will become stronger, habitats will become safer, robots will build before humans arrive, local resources will reduce dependence, medicine will advance, energy production will grow. The first base may become a settlement. The settlement may become a town. The town may become a civilization under another sky. But none of it will happen because Mars became easier. It will happen because humanity became ready. Until then, the red planet will remain what it has always been. Beautiful from a distance, brutal up close. Silent, cold, waiting, not waiting for flags, not waiting for promises. Waiting for a civilization capable of understanding that survival there is not a single heroic act. It is a responsibility repeated every day. The first colonists will wake each morning knowing that the walls around them matter, the people beside them matter, the machines beneath the floor matter, the plants under artificial light matter. Every careful decision matters. And through those decisions, a place that could not naturally support human life may slowly become a home. Not an easy home, not a perfect home, but a real one. That is the promise of Mars. And that is the price. A world that offers almost nothing freely, asking humanity to bring not only technology, but patience, discipline, humility, and care. If we can do that, then one day the question may no longer be what is preventing us from colonizing Mars. The question may become something far more extraordinary. What kind of civilization will we choose to build there? Mars will not become humanity's second home on the day the first crew lands. It will become a home only after the settlers stop measuring their lives by how long remains until they return to Earth. That psychological threshold may be more important than any rocket launch. The first explorers will probably arrive with a mission calendar already written. Their food will be counted, their experiments will be scheduled, their return window will be known. Their equipment will be inspected according to plans created years earlier. They will live on Mars, but their lives will still be organized around Earth. A permanent resident would experience the planet differently. There would be no countdown to departure. The settlement would not be a temporary workplace, but the center of life itself. The red horizon would no longer be a view from an expedition. It would be the familiar landscape outside home. That transition may happen slowly. One crew remains longer than expected. Another decides to stay through an additional launch window. A settlement expands until returning everyone to Earth becomes unnecessary. Eventually, some people may arrive knowing that they are unlikely to leave. Not because they are trapped, because their work, relationships, homes and future have become tied to Mars. This is the point where colonization becomes emotionally real. A settlement is permanent when leaving feels more disruptive than staying, but reaching that stage requires something Mars cannot provide naturally. Security, not perfect safety. No human society has perfect safety, but enough confidence that tomorrow is not constantly threatened by one broken component. The earliest Martian residents would likely hear machinery at all times, fans circulating air, pumps moving water, compressors maintaining pressure, heating systems protecting pipes, computers watching oxygen, humidity, temperature, and carbon dioxide. The silence of Mars would remain outside. Inside, survival would have a sound, the continuous hum of technology. At first, that sound may feel comforting. It means the systems are working. But it would also remind everyone that life depends on them. If the ventilation suddenly stopped people would notice immediately. If the lights flickered, attention would shift toward the power system. If a warning alarm appeared, every other activity could become secondary. A mature settlement would need to reduce this constant tension, not by pretending danger is gone, but by making essential systems so reliable that residents can focus on living rather than continuously checking whether life support will survive the night. That reliability takes time. Machines do not become trustworthy because they worked once. They become trustworthy after years of operation, repeated repairs, unexpected failures, and gradual improvement. The first decade on Mars would therefore be an enormous experiment in endurance. Engineers would discover which materials crack under repeated temperature changes, which seals survive Martian dust, which lubricants continue functioning in the cold, which batteries lose capacity too quickly, which greenhouse designs develop hidden problems, which pipes are easiest to inspect, which electronic systems are too complicated to repair locally. Many of these lessons cannot be learned fully on Earth. Laboratories can reproduce parts of the Martian environment, but they cannot reproduce decades of continuous life on another planet. Mars itself would become the final testing ground. This means early settlers would inherit technology that is advanced but still imperfect. They would not simply use the equipment, they would help redesign it. A habitat built in the first year might look very different after 20 years of local experience. Airlocks could become smaller, stronger, and easier to clean. Spacesuits might be stored outside in specialized ports so dust never enters the living area. Greenhouses might be divided into independent sections to prevent one infection from spreading. Rovers might become easier to repair with locally manufactured parts. Homes might be buried deeper after long-term radiation measurements. Mars would teach humans how to live there, and those lessons would be written not only in reports, but in architecture. Every generation of construction would reveal what the previous generation misunderstood. The settlement itself would become a historical record. The oldest module might be preserved because it was where the first crew slept. A later tunnel might show marks from a major repair after a dust storm. A greenhouse might become famous because it produced the first complete harvest using only locally recycled water. A workshop might be remembered as the place where settlers manufactured a component that once had to come from Earth. These would become Martian landmarks, not monuments built after history, places made meaningful because history happened inside them. A new society needs memory. Without memory, a settlement is only infrastructure. Mars residents would create traditions around survival milestones. The first year without an emergency resupply. The first full season powered mostly by local energy. The first vehicle built partly from Martian materials. The first time a damaged habitat was repaired without assistance from Earth. The first scientific discovery made by someone born on Mars. These events might appear small compared with the first landing, but for the people living there, they would be more important. The first landing proves humans can reach Mars. These later achievements prove humans can continue there. Continuity is the real measure of colonization. One of the greatest tests of continuity would be communication. Earth would remain close in cultural memory, but distant in conversation. The delay means people could exchange messages, but not share moments in the same way. A person on Mars could send a question to a parent on Earth and wait many minutes for the message to arrive. The reply would require another long wait. A conversation that takes 5 minutes on Earth could stretch across an hour. Spontaneity would disappear. People would learn to communicate differently. Messages might become longer and more thoughtful. Video diaries could replace live calls. Families might send recordings that Mars residents watch later. Celebrations could happen twice, once on Earth and once when the messages finally arrive. The delay would create emotional distance even when relationships remain strong. Over time, residents might stop following every event on Earth. News from another planet could feel less immediate than a broken rover or a poor harvest nearby. Earth would remain important, but local life would become more urgent. This gradual change could produce the first true Martian identity, not an identity based only on birthplace, an identity based on shared conditions. Living under lower gravity, measuring time by Martian days, planning around launch windows, knowing the location of every emergency shelter, recognizing the color of an approaching dust storm, understanding that water, power, and pressure cannot be treated casually. People on Mars might see Earth residents as fortunate but careless. Earth people live inside a planet that provides air freely, yet often forget its value. Martians would never forget. They would grow up knowing the atmosphere around them was manufactured. They would understand that environmental protection is not an abstract political idea. It is the difference between a functioning habitat and a dangerous one. This could create a culture of careful resource use, but it might also create strict expectations. Wastefulness could be judged harshly. Ignoring maintenance could be treated as a serious social failure. Personal freedom might be balanced constantly against community safety. On Earth, someone can choose to waste electricity without immediately endangering a city. On Mars, an individual action could affect a small system shared by everyone. A resident who bypasses safety procedures may not be risking only their own life. They may be risking the habitat. This creates tension between freedom and responsibility. How much independence should individuals have inside an environment where everything is connected? Should everyone be required to participate in emergency training? Should personal water use be limited? Should residents be allowed to travel far from the settlement alone? Should someone be able to refuse essential work during a crisis? A Martian legal system would need to answer questions no society on Earth has faced in exactly the same form. The environment would influence law, air would be a shared resource, pressure would be shared protection, power would be a public necessity. An act that damages life support could be treated more seriously than damage to ordinary property. The settlement may develop rules resembling those used on ships, submarines, and remote stations, but expanded into a permanent civil system. This could be one of the most difficult cultural transitions. The first crews might accept strict rules because they volunteered for a mission. Later residents may expect rights associated with ordinary citizenship. A person born on Mars did not volunteer to live inside a controlled environment. They may question rules created before they were born. A society cannot remain frozen in the discipline of the first expedition. It must allow debate, change, and disagreement without threatening survival. That balance would require maturity. Mars will not remove politics. It will make political consequences harder to ignore. Another challenge would be the physical scale of the planet. Mars may look small in comparison with Earth, but it is still an entire world. Settlements separated by hundreds or thousands of kilometers would experience real isolation. There would be no global transportation network at first, no aircraft crossing the planet every hour, no highways connecting every base. Travel might require pressurized rovers, carefully placed shelters, or short-range spacecraft. A journey between two colonies could take days or weeks. This would allow different communities to develop in different directions. One settlement near polar ice may focus on water extraction. Another near ancient lake beds may focus on science. A community near mineral-rich terrain may become an industrial center. A settlement near a major landing zone may become the main connection with Earth. Over time, trade would emerge. Water, fuel, construction materials, food, scientific data, manufactured parts, transportation services. The first Martian economy might not begin with money in the familiar sense. It might begin with resource exchange and shared survival obligations. One settlement sends spare oxygen equipment. Another provides medical support. Another produces fuel for surface vehicles. Interdependence could strengthen cooperation. But it could also create inequality. A settlement controlling water or energy might gain political power. A colony with the only major landing facility might influence who and what arrives from Earth. A manufacturing center might become essential to every other community. Mars would not automatically create equality. Human institutions would still determine whether essential resources are shared fairly. The planet might therefore become a laboratory not only for technology, but for new economic systems. Traditional ownership becomes complicated when survival depends on communal infrastructure. Can someone privately own a water ice deposit? Can a company control a valley where future settlements might be built? Can a government claim territory simply because its spacecraft landed first? What happens if scientific protection and economic development conflict? These questions will need answers long before Mars holds millions of people. The early rules may shape the planet for centuries. This creates a responsibility for people living today. We often imagine that Mars belongs to the future, but decisions made before settlement begins could define that future. International agreements. Safety standards. Environmental protections. Property rules, labour rights. Research zones. Emergency cooperation. These are not distant details. They are part of making colonization possible without turning Mars into a dangerous competition. Competition can accelerate technology, but uncontrolled competition on Mars could produce rushed missions, hidden risks, and settlements built for prestige, rather than survival. The planet does not care which nation arrives first. It does not care which company has the largest rocket. It only tests whether the systems work. A mission driven by deadlines may ignore warning signs. A settlement built to impress audiences may prioritize visible structures over invisible safety. Mars rewards what cameras often ignore: reliable plumbing, protected wiring, spare filters, emergency food, medical training, radiation shelters, careful data, slow testing. The real heroes of Mars may not be the people giving speeches. They may be the technicians who notice a small pressure change before it becomes dangerous, the scientist who discovers contamination in the water system, the mechanic who redesigns a failing rover part, the grower who saves a crop from disease, the doctor who works with limited equipment, the teacher who helps children understand two planets. The importance of ordinary competence would become impossible to hide. This is why the people chosen for Mars cannot be selected only for confidence or public image. They need humility. A person who believes they cannot make mistakes is dangerous in a closed habitat. A person who reports uncertainty early may save lives. The culture must reward honesty more than pride. Near misses must be studied, not hidden. Failures must become shared knowledge. Mars would need a powerful safety culture. Every accident would teach lessons to settlements not yet built. If those lessons are ignored, the same tragedy could happen again. If they are preserved, each generation becomes safer. This slow accumulation of knowledge is how dangerous environments become manageable. Aviation did not become safe after one successful flight. Ocean travel did not become reliable after one voyage. Mars colonization would also require a long history of learning. Some lessons may be painful. Equipment will fail. Missions may be lost. Plans may prove unrealistic. There may be periods when progress slows. The greatest danger may be responding to setbacks emotionally rather than intelligently. After a major accident, some may argue that Mars is impossible. Others may demand faster expansion to prove the dream remains alive. Both reactions can be dangerous. The wiser response would be to understand exactly what failed. Was the technology immature? Was the crew overloaded? Was the mission rushed? Was the supply chain too fragile? Was information ignored? A setback does not automatically prove colonization is impossible. But ambition does not justify repeating mistakes. Mars will require courage without recklessness. The difference matters. Courage accepts known danger for a meaningful purpose. Recklessness hides or dismisses danger to protect excitement. The first settlers will already face enough unavoidable risk. They should not be burdened by preventable risk created by unrealistic promises. Honesty may therefore be one of the most important technologies of colonization. Honest timelines. Honest budgets. Honest medical research. Honest reporting of failures. honest limits on population, honest descriptions of what life there will feel like. The public may prefer stories of rapid cities and easy transformation. Reality will be slower. But a slower dream is not a weaker dream. It may be the only version capable of surviving. A century after the first landing, Mars may still contain only a modest population. Perhaps thousands rather than millions. Perhaps several protected settlements rather than giant open cities. To people expecting instant planetary civilization, this may seem disappointing, but consider what those settlements would represent. Human beings surviving through Martian winters, producing much of their water and oxygen locally, growing significant amounts of food, manufacturing essential parts, raising generations under another sky, conducting science across an entire planet, maintaining transportation between communities, operating with less dependence on Earth every decade. That would be extraordinary. A civilization does not need to be large to change history. The first stable communities on Mars would prove that human life can take root beyond Earth. Not comfortably, not easily, but permanently. And once permanence is achieved, time begins working in humanity's favour. Knowledge improves, infrastructure accumulates, local industry expands. Children grow up understanding the planet naturally. Every generation begins from a stronger foundation than the one before it. The first settlers would struggle to produce oxygen. Later generations may consider oxygen production routine. The first greenhouse may require constant attention. Later farms may be large, automated and reliable. The first homes may be narrow technical modules. Later neighbourhoods could contain gardens, schools, public spaces and architecture designed for joy. The brutal frontier may slowly become ordinary. That is how places become home. Not when danger disappears, when people develop enough knowledge, culture and infrastructure to live with it. Earth contains deserts, frozen regions, storm zones, volcanic areas, and deep oceans that can also be deadly. Humans learn to inhabit many difficult places by building systems and traditions suited to them. Mars is far more extreme, but the principle is similar. Adaptation does not always mean changing the body. It can mean changing tools, buildings, behaviour and society. A future Martian may feel no less at home beneath protective walls than an Earth resident feels inside a house during winter. The habitat may stop feeling like a barrier. It may feel like part of the landscape. Children may know the sound of airlocks the way children on Earth know the sound of doors. They may consider spacesuits ordinary outdoor clothing. They may understand pressure maps as naturally as Earth children understand weather forecasts. Mars would create a new normal. But creating that normal will take more than engineering. It will require accepting that the first generations may live without many comforts expected on Earth. They may have fewer choices, less privacy, limited travel, restricted diets, constant responsibility. A settlement that depends on sacrifice forever will not remain healthy, so each generation must improve life for the next. The first people may accept hardship because they believe they are building something. The second generation will expect proof that the hardship created progress. The third may demand a society, not a permanent emergency station. This is why expansion of quality matters as much as expansion of population. More people inside the same stressful conditions does not create a stronger civilization. Better living conditions do. Larger protected spaces, more reliable food, better medicine, greater privacy, more education, more time for creativity. A colony succeeds when residents can imagine futures not limited entirely to survival work. A child on Mars should be able to dream of becoming a scientist, musician, architect, teacher, explorer, or something not yet invented. If every life must be devoted only to keeping the machines running, the settlement remains incomplete. Civilization begins when some people are free to ask questions beyond immediate necessity. Mars could eventually produce new science, philosophy, art, and technology precisely because of its unusual conditions. Lower gravity may inspire new forms of architecture and movement. The long communication delay may create different styles of storytelling. Closed ecosystems may lead to breakthroughs in sustainability. The need for repair may create highly adaptable manufacturing. The view of Earth from another planet may produce a different understanding of human identity. Mars would not simply copy Earth, it would add something new to humanity. That may become the strongest reason to go. Not to escape Earth, not to replace Earth, but to expand the range of human experience. For the first time, our species could develop two planetary perspectives. One shaped by oceans, forests, and a thick atmosphere. Another shaped by red deserts, engineered habitats, and the constant awareness of environmental limits. Each world could teach the other. Earth could provide biological richness, population, and cultural depth. Mars could provide lessons in efficiency, resilience, and deliberate living. The relationship would not need to be one of rivalry. It could be a shared human project across two worlds. But this future remains far away. Today, the gap between imagination and reality is still enormous. We have not yet landed a human on Mars. We have not tested human health under Martian gravity for years. We have not landed all the equipment required for a permanent base. We have not demonstrated a fully closed life support system operating there indefinitely. We have not solved every problem of radiation, food production, medicine, manufacturing, governance, and psychological health. This is why colonization has not happened. Not because one invention is missing, because permanence requires every essential layer to be ready at the same time. Mars is a chain. If one critical link fails, the settlement becomes vulnerable. That may sound discouraging. It should not. Recognizing difficulty is not the same as surrendering. It is the beginning of serious preparation. The dream of Mars becomes stronger when it survives honesty. A dream that depends on ignoring danger is fragile. A dream that understands danger can become a plan. And perhaps that is where humanity stands now, between dream and plan. We can see the destination. We understand many of the obstacles. We possess some of the required technology. But we have not yet connected everything into a system capable of supporting a society. That work may take decades. Perhaps longer. It may involve governments, companies, universities, international partnerships, and generations of engineers and explorers. No single person will colonize Mars. No single rocket will do it. No single landing will complete it. It will be a collective achievement built slowly. A civilization-sized project. One day, long after the first excitement, someone may stand inside a Martian home and look through a protected window. Outside, dust will move across the plain. The settlement lights will glow beneath the evening sky. A rover will return from a distant site. Children will finish lessons about both Earth and Mars. A greenhouse will begin another growing cycle. Technicians will complete routine inspections. Nothing dramatic will happen, and that ordinary evening may be the greatest success of all. Because ordinary life on Mars would mean the impossible had become familiar. The hostile world would not have changed. The air would still be unbreathable. The cold would still be severe. Radiation would still require protection. Earth would still be far away. But people would have learned how to remain. That is the real destination of colonization. Not a dramatic city appearing overnight. Not a planet transformed by one generation. A stable human tomorrow. Then another. Then another. A chain of days that no longer depends on heroic luck. Mars will always demand respect. It will never forgive carelessness. But it may eventually reward patience. And if humanity reaches that point, the red planet will no longer represent only danger, distance, and failed dreams. It will represent something more powerful. The moment a species born on one world learned how to protect life on another, not by defeating the planet, by understanding it, not by escaping responsibility, by accepting more of it, not by proving humans can survive anywhere without limits, by proving we can recognize limits and build wisely within them. That is the brutal truth about Mars. It is not impossible because it is distant. It is possible because human beings can learn. But learning is slow, survival is demanding, and a real home must be built one careful decision at a time. Mars will not be waiting for the boldest civilization. It will be waiting for the most prepared. And when humanity is finally ready, the first permanent light on the red planet will mean far more than arrival. It will mean we learnt how to stay.